Molecular shape. VSEPR theory. VSEPR stands for Valence-Shell Electron-Pair Repulsion. This theory states that each group of valence electrons around a central atom is located as far away as possible from the others in order to minimize repulsion, because we know that electron and electron, they have the same charge, so they repel. This theory states that those electrons will be located as far away as possible from the others to minimize the repulsion. It is used to predict the molecular shape from the Lewis structure. So if you draw a Lewis structure, this is the drawing of Lewis structure. You just show the carbon bond to 4 other hydrogen atoms, but the molecular shape shows the angle of the electron that repel for each atom. The molecular shape shows the angle and the shape of that molecule. The Lewis structure doesn't show the shape, it just shows how many bonds and which atom is bonded to which. Electron group. In order to predict the molecular shape of a compound, we must identify the electron group of the compound. So the following is counted as one electron group. So if that compound has one bonding pair, the bonding pair, it's either single bond or double bond or triple bond, you have to count that as one electron group. Let's say CH4. CH4 has 4 single bond. So one single bond is counted as one electron group. When this molecule has 4 single bond, it will be counted as 4 electron groups. Double bond will also counted as 1. So CO2 has 2 double bond. When it has 2 double bond, the electron groups is 2. Same goes to triple bond. You don't count how many bond, you count that bond. A triple bond is counted as 1 electron group. A double bond counted as 1. A single bond is counted as 1 electron group. Lone pair. This one. So for lone pair, the pair of electron, one pair of electron is counted as 1 electron group. You have 2 electrons here, but 2 electron is counted as 1 pair. So 1 pair is counted as 1 electron group. When you have 2 lone pairs, so you have 2 electron groups and 1 electron group as single bond and another single bond 1 electron group. So that's why you have the total of 4 electron groups. And for this one, N bonded, single bonded to 3I, so 3 electron group and 1 lone pair, 4 electron groups in total. And 1 lone electron is also counted as 1 electron group. This nitrogen is the central atom. 1 lone pair counted as 1 electron group. 1 lone pair of electron, 1 lone electron is counted as 1. 1 lone pair 1, 1 lone electron 1, and 1 double bond counted as 1. So you have 3 electron groups in total. For calculating the electron group, make sure to calculate on the central atom. You don't count the electron at the surrounding atom or terminal atom. We focus on the central atom only when counting the electron group. There are 5 basic shapes in molecular shape. First one is linear, second trigonal planar, third tetrahedral, fourth trigonal bipyramidal, fifth octahedral. This is the shape of linear, trigonal planar, tetrahedral, trigonal bipyramidal, and octahedral, and they have their own shape and they have their own angles. The general formula for linear is AX2 because it has 1 central atom and 2 surrounding atoms. Trigonal planar, 1 central atom, 3 surrounding atoms. Tetrahedral, 1 central atom, 4 surrounding atoms. And trigonal bipyramidal, 1 central atom, 5 surrounding atoms. Octahedral, 1 central atom, 6 surrounding atoms. But again, this basic shape depends on the electron group. You have to count the electron group first in order to determine the molecular shape. Now, determine by the number of electron group arrangement. Electron group arrangement is the name of the shape. Okay, it's the name of the shape, not the final molecular shape. Electron group are numbers, arrangement as a name. So when you have two electron groups, electron group arrangement is linear. When the electron group is 3, electron group arrangement is trigonal planar. When the electron group is 4, the electron group arrangement is tetrahedral. When electron group is 5, the electron group arrangement is trigonal bipyramidal. And when the electron group is 6, the electron group arrangement is octahedral. Electron group is different from electron group arrangement. Electron groups, the number, electron group arrangement, the name. But this is not the final molecular shape name yet. It is just electron group arrangement. Electron group repulsion. You look at this hydrogen bonding with oxygen, this hydrogen bonding with oxygen. So this is the bonding electron. We call this bonding electron. The electrons that involve in bonding, we call it bonding electron. And the electrons that are not involved in bonding, we call it lone pair electron. Okay, all the electron in bonding and lone pair, they will repel because they are all electron, they all have the same charge. So electron group repulsion for this one, if you look at the lone pair, you have two lone pairs here. These two lone pairs repel with the bonding pair. These two lone pair repel, they are repelled together. This lone pair repel with this lone pair, and it will push this electron downwards and push this electron downward to repel this bonding pair, making the bond angle 104.5. And if you look at this one lone pair only, in H2O you have two lone pairs, but in NH3 you have only one lone pair. This one lone pair only repel with bonding pair, so it doesn't repel with another lone pair like this one. These two lone pairs repel each other, but this lone pair don't have another lone pair to repel, it just repel the bonding pair, and making the angle 107.3 degree. If you compare, this angle is smaller than this angle because lone pair and lone pair repulsion is stronger than lone pair bonding pair repulsion. In this one, you only have electrons that involve in bonding pair repulsion, making the angle 109.5 degree, which is bigger angle than this one, showing that bonding pair repulsion is the weakest repulsion. Okay, lone pair strongest repulsion, lone pair bonding pair weaker, bonding pair weakest repulsion. Steps in drawing molecular shape. Step 1, you have to draw the Lewis structure according to step by step in drawing Lewis structure. And then step number 2, after drawing the Lewis structure, you have to identify the electron group, how many electron groups are in that molecule. After you identify the electron group, you have to determine the electron group arrangement, the name. After you determine the electron group arrangement, then you can identify its molecular shape.